Hello everyone and welcome! Today we are going to get right into one of the most fundamental topics in all of science, the very building blocks of everything around us, atomic structure. Now this stuff isn't just fascinating, it's also super important for your exams. So let's get focused and dive right in.
So here's our game plan for today. We're going to start with the absolute basics. What even is an atom? Then we'll take a look inside one. After that, we'll figure out how all those electrons get arranged, we'll talk about shells and subshells, and finally we'll see what happens when atoms team up to form molecules. It's a nice, clear path to really getting this stuff.
Okay, first things first, let's tackle our first big topic. What is an atom? We're going to answer that one fundamental question. What exactly is this thing we call an atom?
But before we jump into the what, let's give a quick shout out to the who. Our understanding of the atom today was really built on the shoulders of giants. You had John Dalton, who first came up with the whole idea, then Ernest Rutherford came along and figured out its basic structure. And after that, Niels Bohr gave us the model for how electrons are arranged in these things called shells. Their work was, and I mean this, absolutely revolutionary.
So, let's boil it down. What's the simple definition? An atom is the smallest possible piece of an element you can have. Think about it like this. If you took a piece of gold and just kept cutting it in half over and over, the atom is the point where you just can't cut it anymore without it stopping being gold. You'll definitely want to remember that definition. It's a perfect one-liner for any test.
All right, now that we know what an atom is, let's do something fun. Imagine we could shrink ourselves down, way down, and take a look inside one. You might be surprised. It's a pretty busy little place in there. Ready? Let's go.
The easiest way to picture an atom is to think of it like a tiny solar system. Right there in the middle, you've got the nucleus. That's kind of like our sun, and packed super tightly inside that nucleus are the protons and the neutrons. Then, zipping around that central core, like planets in orbit, are the much smaller electrons.
Okay, I need you to really focus on this table. It is absolutely essential. We've got our three key players. First, the proton. Its symbol is P+, and just think P for positive. It's got a positive charge. Then we have the neutron, symbol N0, and as the name suggests, it's neutral, no charge at all. And finally, the electron, symbol E-, which has a negative charge. These three particles and their charges, they're literally the foundation of all of chemistry.
And now, for the part that I think is really cool. Those electrons we talked about, they aren't just buzzing around the nucleus in a chaotic mess. Oh no! They actually follow a very specific set of rules, moving in very defined paths. It's not chaos at all. It's more like a beautifully organized dance.
And this is where that guy Niels Bohr comes in again. He's the one who explained that electrons orbit the nucleus in specific energy levels, which we call shells. The shell that's closest to the center is called the K shell. Then as you move out, you get the L, M, and N shells. A really good way to think about them is as designated homes where the electrons get to live. So, how many electrons can actually live in each of these homes? Well, for that, we have this wonderfully simple little formula, and trust me, you're going to want to remember this one. 2n squared. It's a lifesaver on tests. And that letter n there, it's just the shell number. Simple as that.
Let's actually put that formula to work and see how easy it is. So for the K shell, that's the first shell, right? So n is 1. We plug that in. 2 times 1 squared, that's 2 electrons, max. For the L shell, n is 2. So 2 times 2 squared gives us 8 electrons. See the pattern? The M shell can hold up to 18, and the N shell can hold a whopping 32 electrons. Pretty straightforward, right?
Okay, so we've got the main homes, the shells. But the story doesn't quite end there. There's another layer of detail. It turns out that within these shells, there are even smaller divisions. You can think of them like different rooms inside a house. So let's take a deeper look.
And this brings up a really good question. Where exactly are the electrons inside a given shell? I mean, do those 8 electrons in the L shell just kind of float around anywhere they want within that energy level? Well, the answer to that is a very definite no.
And the answer is the concept of subshells. Each main shell is broken down even further into these subshells, which you might also hear called orbitals. They have their own distinct shapes, and they're named S, P, D, and F. As you can see here, that first shell, K, it only has one type of room, an S subshell. But the second shell, L, has both S and P subshells, and that pattern just keeps going.
This table right here, this is where it all clicks into place. Look, those 2 electrons in the K shell, they both go into its S subshell. The 8 electrons in the L shell get split up. 2 of them go into its S subshell, and the other 6 fill up the P subshell. And the principle is exactly the same for the bigger M and N shells. And notice this. If you add up the electrons in the subshells, what do you get? You get the total capacity for that shell that we already calculated. See how it all connects?
Wow. We have explored the entire world inside a single tiny atom. But here's the thing about atoms. They rarely stay alone. They're very social. So for our last section, let's see what happens when these individual atoms decide to team up.
So, when 2 or more atoms join together, held by something we call chemical bonds, they form a molecule. That's it. If you think of an atom as a single Lego brick, then a molecule is the cool thing you build when you start clicking those bricks together.
Let's just make this distinction perfectly clear because it can be tricky. A single O for oxygen, that's an atom. A single Na for sodium, that's an atom. But when 2 oxygen atoms bond together to make O2, now that's a molecule. Same thing with HCl, which is hydrogen chloride, or N2, nitrogen gas. Basically, if it's a single symbol, it's an atom. If it's a combination, it's a molecule.
And of course, molecules can come in different sizes. Take O2, for example, the oxygen that we breathe. It's made of 2 oxygen atoms, so we call it a diatomic molecule. That di prefix just means 2. Then you have something like ozone, which is O3. It has 3 oxygen atoms bonded together, so we call that a triatomic molecule. Tri, meaning 3.
Okay, to finish things up, I want to leave you with a bit of a mind-bending question. Physicists have figured out that atoms are actually more than 99.9% empty space. So, if you and me and the chair you're sitting in are all made of atoms that are mostly nothing, why does everything feel so solid? It's definitely something to think about. And that is our deep dive into the incredible world of atomic structure.